We now discuss the solution of a problem from the section Permutations and Combinations. The given problem is on the counting of 5-digit numbers that are given in the question. This question has appeared in the Joint Entrance Examination Main held on 28th June 2022 in the first shift. The given question is the total number of 5-digit numbers formed by using the digits 1, 2, 3, 5, 6, 7 without repetition, which are multiple of 6 is. We are given 4 options. Option A 36, option B 48, option C 60, option D 72. So we are given 6 digits that are 1, 2, 3, 5, 6, 7, and we have to form the 5-digit numbers using these digits without repetition, and those numbers are to be multiple of 6. Then we have to find the total number of such 5-digit numbers using these 6 digits without repetition, which are multiple of 6. We now discuss the solution of the problem in detail. Recall, if a positive integer is divisible by 3 and 2, then the number is divisible by 6. And we know the divisibility rule for the digit 3. A number is divisible by 3 if the sum of the digits of that number is divisible by 3. The sum of the given 6 digits, what are the 6 digits? 1, 2, 3, 5, 6, 7. The sum of these 6 digits is 24, which is divisible by 3. But we have to form only 5-digit numbers using 5 of these 6 digits. Agreed. So we are here, and the sum of the 6 digits is 24. And suppose we form a number, 5-digit number, without 1. So 1 is not there. Then we have 5 digits. Agreed. But the sum of the 5 digits is 23, which is not divisible by 3. Therefore, 1 cannot be removed. So let us say we remove 2. Then we get 5 digits, 5 digits we get. And the sum of the digits is 22, which is not divisible by 3. And if you remove 5, then 24 minus 9, 19, which is not divisible by 3. Therefore, 5 cannot be. 7 also. But suppose we remove 3. Then from 24, if you subtract 3, it is 21, which is divisible by 3. That means the 5 digits what you can take is 1, 2, 5, 6, 7. The sum is 24, which is divisible by 3. Agreed. And if we remove 6, then 24 minus 6 is 18, which is divisible by 3. Therefore, we have the second choice, that is 1, 2, 3, 5, 7. The sum of the digits is 18, which is divisible by 3. So, what we get, there are 2 choices of choosing 5 digits of the given 6 digits such that the sum of all the digits, sum of those 5 digits is 3. And what are the two choices? This is the first choice and this is the second choice. They are, first choice is 1, 2, 5, 6, 7. Second choice is 1, 2, 3, 5, 7. Now, we have to choose, we have to, form 5-digit number using these digits without repetition and which are divisible by 6. Now, the divisibility by 3 we have already tested and we got these two choices, and go for the divisibility of 2. It is now sufficient to form even numbers divisible by 2 with the above 5 digits. That is, the unit place of the number must be 2 or 6 in the case of first case. In the second case, the units place must be 2. Agreed. We deal with 2 cases in the next slide. That's what we have done. And the case 1 is the digits are 1, 2, 5, 6, 7. And we deal with 2 sub-cases. Why? Because in the units place 2 can be there or 6 can also be there. So case 1a, let the unit place of the 5-digit number be 2. This is a 5-digit number, units place is 2. Agreed. Now the remaining 4 places are to be filled by 1, 5, 6, 7. Suppose this first place is filled by any one of them. We have, from these 4, we have 4 choices. Having filled the first place, we have 3 choices to fill the next blank, next place. That is 3 choices. Having filled the first 2 places, we are left with 2 choices, two digits, and the third place can be filled in 2 ways, and the last one, there is no way, 1 by 1 way. That means in factorial 4 ways you can do this. So this can be done in factorial 4 ways. Why? We have to use the product rule, 4 into 3 into 2 into 1. That is factorial 4 ways in the case 1. Let's go for the case 1a, case 1b. Let the unit place of the 5-digit number be 6. Instead of 2, it is 6. The remaining 4 places are to be filled with 1, 2, 5, 7. This can be done in factorial 4 ways as above. So the number of 5-digit numbers formed by using the digits 1, 2, 5, 6, 7 without repetition, which are multiple of 6, is done by factorial 4 plus factorial 4 is equal to 48. This is by sum rule of counting. Sum rule of counting. So in the case 1, we got 48 ways of forming those 5-digit numbers. Agreed. We continue in the next slide for case 2. So we go for case 2. The digits are 1, 2, 3, 5, 7. And the units place be filled with 2 only. There is no other even number in this. The remaining 4 places can be filled by 1, 3, 5, 7 in factorial 4 ways, as we have done in the case 1. Agreed. So the number of 5-digit numbers formed by using the digits 1, 2, 3, 5, 7 without repetition, which are multiple of 6, done by factorial 4, that is equal to 24. Only one case we get, this one. Now combining case 1 and case 2, so that means we use the sum rule again. The total number of 5-digit numbers formed by using the digits 1, 2, 3, 5, 6, 7 without repetition, which are multiple of 6, is done by 48 ways in the case 1 plus 24 ways in case 2. We use the sum rule, and 48 plus 24 is equal to 72. So let's look at our options. Our answer 72 appears against option D. Therefore, the answer to this question is option D. That is the detailed discussion of the solution of the problem, which is on counting 5-digit numbers that are given in the question. And this question is from the section Permutations and Combinations. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.